The purpose of this project is to develop a Thevenin and Norton equivalent circuits lab that uses MyDAC. The lab will be based on a lab previously used at UND, which uses more conventional, basic test and measurement equipment. The student who will be doing the lab should complete the pre-lab prior to doing the lab, preferably before class time. The pre-lab should not require the student to have access to lab equipment. Therefore, the existing pre-lab, which requires the use of multisim, which is available through Citrix, will not be revised to use MyDAC. As I read through the lab that was provided for the project, I noted the sections that would need revision to accommodate the use of MyDAC. As part of making these revisions, it is assumed that the student has some familiarity with MyDAC from previous labs. The first use of MyDAC in the lab is to create the VI that provides the 5 volts DC. Because the lab is not digital, I chose to use A00 to generate the 5 volts. I documented each step as I created the VI, then went back and used the steps I had written to recreate the VI to ensure the steps were accurate. Now here are the steps to generate the 5 volts. Oh, that's the multimeter. And there's the VI. And this was added as a figure. And I use the same method to create the steps for setting up the digital multimeter. And as I said, figures were added to the lab to show the VI and digital multimeter setups. So there's your VI. Let me make those small. Now you can see the multimeter. You can set up. And I also made sure to reference the banana jack connections to make sure those were correct. There's the figure for the LabVIEW VI and the multimeter setup. I also included a figure showing a sample layout of the circuit on the protoboard. And it's noted in the figure that these resistors won't satisfy the lab. The resistors are just shown there for an example to show the layout. Because it's also noted in the lab that you may need to use a combination of resistors to get the design values that you need. But this is just a simple one that shows a one-to-one relationship for each resistor value to give kind of a sample layout of the connection on the board. Here's my actual circuit layout on the proto board. I had to use a combination of resistors to get the right value for R4. I didn't have the exact value. So that's something I think I included that in the lab notes for the students so that they understand that they could do that as well, which, you know, maybe they've probably already figured out from previous labs, but it's in there anyway. Here I have a copy of the lab report my group submitted for the original lab. Rather than submit just the lab report for the MyDAC lab, I have chosen to submit my copy of the original lab report with added data from the MyDAC lab, results and comments where the two lab reports might differ. This is to highlight that the student will learn the same concepts just as effectively with MyDAC lab as with the previous lab. So in sections like this, the MyDAC information has not been added yet, but I would add another table and note that it's for the MyDAC lab. And that gives us a little comparison of how effective the MyDAC lab is and how accurate it is compared to a lab that was performed using the other test and measurement equipment. And that will be submitted as part of my submission for the lab report. And that's the end of the video. Thank you.